Hi everyone, and welcome to this episode of Keipert Labs. In today's episode, we're going to be discussing the principles behind oxidation and reduction. So we're going to talk through, remind ourselves of what we mean by these words and these concepts of oxidation and reduction as chemical changing processes involving electrons. I'm going to give you some tips and tricks about how to remember which is which. We're going to introduce labels that we call oxidants and reductants as an alternative kind of terminology. And then we're going to go through some examples of both oxidation and reduction. Okay, so oxidation and reduction, we introduced them in the previous video in situations where we have electron transfer reactions. So where a chemical change is occurring because of the transfer of electrons from one reactant or one species to another. So one is undergoing reduction, which was the gain of electrons. The other species is undergoing oxidation, which is the loss of electrons. Okay, so electrons are being transferred or moving from one thing to the other, and so we have these two processes occurring at the same time. Okay, so we call these oxidation reduction or redox reactions. Okay, so we don't tend to refer so much to the term electron transfer reactions. We tend to substitute redox reactions as the term that applies, because this is the process of these two processes of electron transfer. Okay, so now the key thing about redox reactions is that both of those two processes are occurring simultaneously. Okay, so when one is giving or losing, the other is taking or gaining. Okay, that those electrons don't just kind of vanish into nothing and then pop back out of nothingness in the universe somewhere else. That they are transferring from point A to point B. Okay, and they must occur together. That we must get both processes, an oxidation and a reduction. You can't get two things oxidizing and two things reducing. Okay, you must have both. Okay, so well, I've kind of got two here, two little tricks to help you remember which is which. The first one that I would suggest is the one on the left, which has the little red letters. So which is the acronym OILRIG. Okay, oxidation is loss and reduction is gain. OILRIG. So oxidation is a loss of electrons, reduction is a gain of electrons. Now, when I was at school, the way that my teacher taught me, which might be a different way to help you, is that oxidation offers and reduction receives. So the alliteration of those same letters. So whichever of these techniques helps, or if you've got some other process that might be useful. Because the challenge here is that you've only got two processes, but that means you've got a 50-50 chance of labeling them correctly, and students often get them around the wrong way. So you need a technique to help you remember which is going to be which. Okay, and so now what we also have when we're thinking about redox reactions is that we've also, sometimes we don't want to think about as much about what is happening to a particular species as much as the effect that it's causing in something else. Excuse me while I just kind of get myself a bit more comfortable. So we often come across the label of oxidant and reductant. So oxidant is short for oxidizing agent, the agent of oxidation, causing oxidation in another species, and is therefore itself reduced. When you've only got two processes, that must be what's occurring. So an oxidant is itself reduced, but is an agent of oxidation in something else. And so depending on our situation, that might be what's most relevant, that it causes oxidation. Okay, and likewise a reductant, or it's a reducing agent, causes something else to be reduced and is therefore itself oxidized. Okay, so we use these labels because they, depending on the context, they are quite relevant. You need to be familiar with the terminology and the fact that they kind of, it seems a little bit back to front, that the reductant is actually the thing that's being oxidized, but it's a perspective thing, okay, or a frame of reference thing, perhaps for the physicists out there. Okay, so we've got some examples here of oxidation and reduction, so showing in each of these situations that we're losing, a substance is losing electrons. Okay, so notice that the electrons for oxidation equations are on the right-hand side, they're on the after side. So iron metal becoming iron 2+, silver metal becoming silver 1+, and then this one, which is more complicated, chromium 3+ becoming this dichromate ion, Cr2O72-. You can see there's a whole lot of other substances in there in order for that chemical change and that rearrangement to occur. The reduction ones, notice the electrons are present on the left-hand side of the arrow in each of these situations. So copper 2+ becoming copper metal, iron 3+ becoming iron 2+. Notice in that one that there is no solid metal, but there is still chemical change. And then the permanganate ion becoming manganese 2+. Okay, So we've reminded ourselves about the principles behind oxidation and reduction as those two processes involving loss or gain of electrons. We've introduced some little terminology to help you remember which process is which. We've introduced alternative terminology of oxidants and reductants, where we're thinking about the effect it has on something else, and some examples of both. All right, thanks very much for watching. Bye for now.